Hello everyone. Hi, very good afternoon and welcome to Unify Study everyone. Very good afternoon. All of you are fine. How are you all? After a long time I came live in this time, right? And I'm sorry for that. For a long time I was not able to come live at this time. And now finally I came live and I decided that yes, every day I will come live again. Because whenever I am trying to record video, then recording video will be not done. Whenever you are planning to do something, then it will be gone. Just we have to decide, now only I have to do it. So whenever I am scheduling the live class, means I have to join live class anyhow. Although I am little bit late, till now I am little bit late. So it's okay, finally I came live, and it is the 45 days crash course going on. You know that already so many classes we did, already so many classes are there in this YouTube channel of the 45 days playlist. Must watch it everyone. And those who are not watching the 45 days playlist must watch it, because so many topics already I cover there, and those are the topics are remaining. That topic I am going to cover now. More 20 classes I will provide here for computer science. As I told, all 10 unit I am going to cover all the important topics of 10 unit. Already we have covered the software engineering, TOC, networking, data structure, algorithm, discrete math. All these topics are done. And DBMS also I have uploaded video, operating system also I have uploaded video, networking also all the videos are there. Yes, all these videos are already there in this playlist. So whatever not present, that is I am going to cover here. Those who don't know about this must go through this channel, go to this channel, go to my channel, view my channel Unify Study, and here you can come to this 45 days crash course and must complete each and every classes of this 45 days playlist, because here everything is for you. Everything you can see from here: graph theory, after that your data structure algorithm, software engineering, TOC, then after that computer architecture, then networking, data, operating system, and finally now we are doing database. And in this database already transaction and concurrency, one part serializability we did already serializability. I hope you already watched that, because in transaction and concurrency first part is the serializability, and that is very important topic. And after serializability, next topic I am going to do, that is all the protocol. From all the protocol questions are coming, and that is I am going to do, and each and every classes will be added in this crash course only. In this crash course only each and every classes I will add, so that there will be no problem to find out. You can find out all everything. And those who are new to this channel, definitely subscribe to the channel, click the bell icon to get all the latest update and notification, and to be connected with this channel, because in this channel you will get everything, right? You are going to get everything. AI, we will start AI after DBMS completion. DBMS and little bit operating system, some topics are there. After completion of this I will start. Okay, yes, take care. Chalo, let's start everyone. Without wasting time, let's start. So in transaction management, first of all, this is the first question coming under transaction management, that is asset property. Why the transaction is required? When you are sending money, receiving money, that is a transaction, right? When the transaction is required, transaction is that one when you are transferring money transfer is going on, that is a transaction. Money transfer is a transaction, right? Yes. Yes, so sequence of many action when considered to be one atomic unit work, that is a transaction. And here that's why the asset property. What is asset property? Asset property means atomicity, consistency, isolation, and durability. From here questions are coming. Asset property as atomicity, consistency, isolation, and durability. This is very important. What is acid property? Atomicity means, what is atomicity? Atomic. Atomicity means atomic. It's required each transaction is all or nothing. Either complete everything or do nothing. Either complete everything or do nothing. That is called atomicity. Okay, there will be no in between something. Okay, 50% I did and 90% I did. In between anything is not possible. Okay, yes, clear. Next one is the consistency. What is consistency? If each transaction, as I am, is that clear to everyone? Got it? My voice, audio, video, everything is clear to everyone? Yes or no? My audio, video, everything is clear, right? Please reply. I am not getting your chat. Okay, yes. Consistency. Consistency means if each and every transaction is consistent and the database start on the consistent, then end will be also consistent. Start inconsistent and end will be also consistent. That is called consistency. Okay. Next one, consistency means your learning should be also consistent. Sometimes you are learning too much. Before exam you are learning too much and after that you are sleeping. That is not consistency. Consistency means regularly you have to learn. Regularly you have to learn. Now you have 30 days before exam, right? In this 30 days regularly if you are learning 4 hours, 5 hours, 6 hours, then at the end you will get a good result. But if you are thinking whole night study I will do before exam, that is not consistency. Consistency means everything you are doing normally as it is. As it is, everything is going on. That is called consistency, right? Starting also consistent, at the time of end also it is consistent. So your database is consistent at that time. Isolation. Isolation, this word is also very important. What is isolation? Execution of transaction is isolated from another transaction. Means what one transaction is doing, another transaction will not interfere there. It is isolated from another one. I will do my work separately, you will do your work separately. These are two different separate work. So that's why this is isolation is very important. Isolation, you cannot interfere. Two transactions cannot interfere between each other. Okay. Next one is the durability. Durability is related to time. Your data should be durable, means you cannot say that okay I invest my money, maybe you invested 1 lakh money in your bank. After that, after some time bankers are telling you no, the money is not there. Is it possible? The money is not there now. If they are saying that now money is not there, then definitely you will not allow them, right? So that should be durable. Your data should be there. Whatever there, it is power crash, data crash, maybe power crash, server crash, whatever it is, but that security should be there, that assurance should be there, that it should be durable. It should be durable. That is called durability. And here main two operations are there, that is commit operation and rollback operation. Commit means it is permanently you are going to store it. That is called permanent store. If you are not committing the data, means it is not the permanently stored. After commit operation only database will store it permanently. Rollback means what? You want to revert back. Something you did, you want to revert back it. That is called the rollback operation, and rollback is reverse the changes. Okay? Yes, these are the two main important work. Commit and roll back in database. Now here whenever this is also questions are coming from acid property, already 2 to 3 times question came, and here this is the question came from here, that is the transaction. Here under the transaction, whenever begin transaction, Transaction state of the transaction. From here also questions came previously. Begin the transaction, read item, write item, end the transaction. It can be partially committed after ending. It can be fully committed. It can be abort also. After partially commit, it can be abort and it can be failed also. Here active, from this state also it can be abort and it can be failed. And after that totally this transaction can be aborted also. Yes. Yes, very good Minachi, very good. Next one is that serial and serializable. This topic I already covered in the last class. And I uploaded the video for this. Detailed video is there. Serializable, serializability, view serializability, and your all that topic I already covered, right? What is the view serializability and all. Next thing is that these are the some problems, some typical problems under the concurrency protocol, concurrency problem. These are coming. Questions also coming from here. This from here also questions are coming. Lost update problem, uncommitted dependency problem, inconsistency problem, the inconsistent analysis problem, non-repeatable read, phantom read. By looking they are very close, but from here when theoretical questions are coming, students are getting confused. They will give you a situation, after that they will ask you it is what type of problem. Is it lost update? Is it phantom read? Is it uncommitted dependency? Then you will be confused. So that's why you have to understand it. It is totally theory. This topic is totally theory, but 100% confirm from this whatever I am going to tell you today. From here always questions are coming. And that's why take your pen and paper. All of you, are you ready with your pen and paper? Are you ready with your pen and paper? Minachi, Monica, Vanita, Prathiva, Kishori, Arun, Full Moon, Manikam, Vinu, Hari, Lakshmi, Aruna, Ammu, Gandhimati. All are ready? Poonam. All are ready? Yes, all are ready with your pen and paper. Okay, pen and paper is very important, because the points you will write down here. Lost update, when it's happened? It's happened when two transaction access and update at the same data simultaneously. Here is a variable A in the account. There is that account. Now you are also accessing and your mom is also accessing. You both have a joint account. You are also accessing, your mom is also accessing. At the same time you are trying to add something here. At the same time your mom is trying to take something. Means you are trying to add 1000 amount and your mom wants to take it 1000 amount simultaneously. Now what can be problem? And the result of one is overwritten by another one. Means initially in the account there was 2000 rupees. Okay, now you are trying to make it 2000 plus 1000, that is 3000. And your mom is trying to make it 2000 minus 1000, that is 1000. In a same account, joint account, it is a joint account, in a same account. You are doing from somewhere, your mom is doing from somewhere. Now what will be happen? You are adding this and now it should be 3000, but it is overwritten by your mom to 1000. It is overwritten by your mom to 1000. This is a problem. This problem is called lost update. Means your update that was 3000, that is lost. That is lost. So ultimately what should be happen? If you are doing also at the time of consistency, what should be happen? 2000 plus you are adding 1000, your mom is deducting 1000, at the end it should be 2000. But what happened here? The 3000 is updated to 1000 and account is showing now 1000. Means actually this 1000 amount is lost. This 1000 amount is lost now, and that is called a lost update problem. This is a very typical problem, that is called that lost update problem, right? So read the value of x, add 3 value, assign this value, the just example I took. Next one is the uncommitted dependency problem. Uncommitted dependency problem, that is called dirty read. This is called a dirty read. Dirty read means what? Suppose today we have the data beginning at the updated eventually and roll back in the transaction. A dirty read occur when the transaction running concurrently, means I am telling example. A account was 1000. Now you are trying to add more 1000 rupees. Now it should be 2000. Means you are when you are purchasing something, when you are adding something, when you are doing some payment somewhere, right? You are doing some payment somewhere, so your money is deducted from your account, but after that transaction fail. This type of problem are happening. Means what? Ki although it is right operation is done, but it is not committed. It can be happen that you are trying to pay 1000 rupees for the UGC net form fill up. You are giving 1000 rupees, and after that transaction failure. After that transaction failure, everyone is facing that problem. You are paying money and it's not coming. What is the problem? At that time you in your account there was 5000. Now you pay, so that's why now it is showing in your account 4000. But actually it is not the committed data. Now someone else read that in your account now 4000 amount is there. But after some time this 1000 is revert back and now it is 5000 again. Right? But at that time which transaction checked that, they checked that in your account now 4000 is there. So this 4000 read, this read is actually a dirty read because it was a uncommitted read. This write operation was uncommitted, and at that time only someone read that data, and that is a dirty read problem. Before commit operation, if someone else is reading that data, that is called a uncommitted read, uncommitted dependency or dirty read problem. Clear? The difference is clear, very close. They are very close, but situation are different, and regarding this situation questions are coming. That is very important to understand. Now inconsistent analysis, inconsistency and MCQ practice we are doing at 7 PM class. Join 7 PM class for doing MCQ practice. 3 PM we will do remaining concept, whatever pending concepts are there, that I will cover, and 7 PM I will take the class for MCQ. There we will practice the MCQ. So join 7 PM class to do the MCQ practice. Okay, 7 PM, or I will try to start at 6:45 PM. I will try to start at 6:45 PM. That will be better. So within 6:40 to 7, within this time I will start. Okay. So try to join so that you can do the MCQ practice. Inconsistency analysis problem. Inconsistency means inconsistent analysis when transaction read the data which another transaction still updating. Like that in WhatsApp. Nowadays in WhatsApp the feature is there. After sending message, within some time you can edit the message also, right? That is there. Yes, nowadays it is there. Now you are writing something and you are editing. You are writing something and you are editing. At that time someone is reading that data. That is called an inconsistent read. Means you read something, after that you are thinking no, I don't want to write it. You are editing that. You are editing that, and in between your receiver already received that data and she is reading it. That is called a inconsistent analysis problem. Transaction read a data which another transaction still updating. Got it? That is a inconsistent analysis problem. Non-repeatable read. Whatever I am given in the red line, the highlighted line, write down those highlighted line in your notebook so that you can do the question, theoretical question. Non-repeatable read. Non-repeatable means non-repeatable read occur when read the same row multiple times but obtain different subsequent value. You are reading the same values, but you are reading the same row. Just now you read that row, there is something different, that is A is given 1000. Now you are coming back and you are reading it, now this is showing 2000. That is a non-repeatable read. Because another transaction update the row at the same time. Just now you read, array here is 1000. And another transaction at that time it's make 2000. And within a second you can see 2000 that is. So this is a unrepeatable read. Non-repeatable read. Okay. Phantom read. What is phantom read? Phantom read is the problem when transaction is executing insert or delete operation. When it is executing insert or delete operation on the set of rows that are being read by another transaction. That is called phantom read. Phantom means insert or delete operation on same row. It was there and it is by another one, it is deleted. So it is a ghost. Now it is not there. That is called phantom read. Okay. Clear? Yes, hi ma'am. If we paid online payment 2 times due to some error, after that received amount from that connection, could you say what type of problem? That was uncommitted because the transaction was uncommitted. Right, you are getting back means it is a uncommitted transaction. That's why it is revert back. If it is already committed, then it cannot be revert back. It is a uncommitted and that's why it is roll back. That is the example of roll back. Revert back means what? That is the example of roll back. Got it? Yes. But at that time when you are sending, but at that time someone reading it, that will be an inconsistent analysis problem. Clear? Yes. Now here are the different type of schedule in database. Serial schedule, non-serial schedule, serializable, non-serializable. Serializable, under that the conflict serializable and view serializable. Non-serializable, under that recoverable, non-recoverable. Cascading schedule, cascadeless schedule and strict schedule. ठीक है. These are the all schedule. Hi मैम, आपके PYQs देखने के लिए प्लेलिस्ट बनानी है क्या? आपने प्लीज बताएंगे. PYQs is paid course. PYQs MCQ is the paid course on Unified Study platform. If you want to take it, then you have to take the paid course. All PYQs class is going on 5:30 AM morning. I am taking class on Unified Study platform. Unified Study website is there, app is there. For that you have to purchase that course. And now the offer is going on Super 20. Super 20, using this coupon you can purchase the paper 1 plus paper 2, both course are available in 2000 rupees. Paper 1, paper 2 both combo batch is there, which is showing 2500, but after applying this coupon code Super 20 you can get it in 2000. So all PYQs of paper 1, paper 2 you can avail there. Now YouTube पे all series नहीं है. No, YouTube पे नहीं है. YouTube पे पूरा series complete नहीं है. Sorry. Everything is not possible, right? Yes. So here cascading schedule and cascadeless schedule and strict schedule. Cascading schedule is this one, that is when this already done. Conflict schedule and view serializable. Conflict serializability and view serializability already I covered. Now what is this is serial and parallel, that is also we did serial parallel. Now the recoverability, this is a very important topic. Recoverability. Recoverability means T2 is the reading. If T2 is reading the data item which is written by T1, T2 is reading it which is written by T1, then T2 should commit after the T1. You can see what is going on. Here A operation read A. Now it is doing A minus 50. Now the write operation is done. In between T2 is reading that data and T2 commit also. But T1 did not commit it. T1 did not commit it. Before that only T2 read it and T2 commit it also. So what T2 read here, if the account there was 100 in the account, and from here A minus 50 means now 50. Now write operation is 50. Now it will read 50 and it will commit also. So T2 is taking A equals to 50. But now the transaction failure here. Here the transaction failure. And that's why T1 tries to roll back. Means T1 will be revert back to 100 only. But the problem is that this is revert back here, but this is cannot be revert back, right? Because it is already committed. T2 cannot revert back it because T2 is already committed. That is not possible. And that's why it is called irrecoverable schedule. Whenever someone is reading a uncommitted data, that is called irrecoverable schedule. Very, very important. Remember that. Next one is the cascading rollback. Cascading rollback means someone write it. In the A there was 50. Now it is writing A equals to 100. This one is reading A equals to 100 and it is writing now 200. Now this is reading 200 and it is writing now 300. And after that now this is reading it 300. Now what is happened? Now the problem is that okay, this one is failure. Here is the failure. Whenever here is the failure, then this one rollback means this one had to be rolled back. This one also should be rolled back. This one also should be rolled back. Because why the problem is there? Everyone is the uncommitted. Everyone was uncommitted, and as this one rollback, so everyone should be rolled back. And that is called cascading rollback problem. Cascading rollback problem. Is that clear? Yes. Is it clear? Now this chart will be very, very important for you. Irrecoverable, recoverable, cascadeless and strict recoverable. Very important. Irrecoverable means you can see someone is writing. After that not committed. Before that it is reading the data and it is committing the data. That's why this is irrecoverable. T2 commit before T1. This one is recoverable because why? Because it is writing operation done. This is also reading. Before commit only it is reading. But this one committed fast. After that this one is committing. That's why it is recoverable. Because in between if some failure is there, then it can be rolled back. This can be also rolled back. Because before this commit, after this commit only this commit operation is done. That's why it is not possible. This is possible, right? Cascadeless recoverable. Cascadeless means someone writing, after that committing, then only it is reading. So if there is anything roll back, it will only roll back. And there is no need to be here roll back, because after commit only I am reading your data. So there is no dependency like uncommitted read. That's why it is cascadeless. Strict recoverable means writing, then committed, then read or write whatever is going on. No uncommitted read or write. That is called strict recoverable. It is strictly recoverable. Read, write, whatever you are doing, you have to do after commit operation only. Got it? So tell me, what you understand? What you understand till now? What are the different types of transaction I told you? What is irrecoverable? What is recoverable? What is cascadeless recoverable? And what is strict recoverable? Write down in the chat box, everyone. What is your understanding? What is your understanding? Write down in the chat box. And those who are watching, please like, share, subscribe. You are watching but you forgot to hit the like button. You can hit the like button, I hope so. Yes or no? Definitely you can hit the right like button. Yes. So tell me what you understand here. What you understand about that? Answer you are telling, but I am asking you what you understand. Write down in the chat box. What is irrecoverable? What is recoverable? What is cascadeless? And what is strict recoverable? Okay, full moon is giving the answer. Irrecoverable. T2 commit before T1. Answer, all of you are giving answer. That is correct. Option D is the correct answer. Okay. So here it is asking T1, T2 allowed the update same way A uncontrolled manner. Then what are the scenario can be occurred? Dirty read problem can be occurred. Lost update problem can be occurred. Inconsistent database state can be occurred. Transaction failure, it is not related to anything. It can be happen anywhere. It can be happen anywhere, right? Definitely it can be happen anywhere. Okay, very good. Concept clear with before and after T1, T2 read write. Okay, very good, very good. So now this is the here serializability, serializable schedule characteristics. This all are done. Must watch that video of conflict serializability and view serializability. That is already done. I am not going this. These are the topics are already done and question is also done. Now I am coming to view serializability. Topic is also done. I completed this topic. Here is the log based recovery. This is another topic, but is called deferred DB modification and immediate DB modification. Two types of are there. What is called deferred and what is deferred means late. Deferred means late. Always remember the deferred word came from late. Means what is the deferred? Always store the new value in the log. It will always store the new value. It stores the updated new value by only after commit the database. Whenever it is committed, then only it is storing only the new value here. And immediate database is doing that. After changing the new value, it immediately stored into the database and did not wait for the commit. Whenever you are changing it, it is storing into the database before commit operation also. And it is storing the old and new both. That is the main difference. It is storing old value and new value both, and it is storing only new value. It is storing the data before commit. Before commit only it will store the data, and it is storing data after commit only. Okay, that's why here what it is, the recovery system must prefer the redo operation. Here it can do the redo operation, and here it can do redo and undo both. Here this one can do redo operation also and undo operation also, but it cannot do the undo operation. Why? Because to do the undo operation, the old data is required. You are writing something, you are doing Control Z. Control Z means what? You are trying to revert back to old value. So when the old value is there, then only you can revert back, right? If the old value is not present, can you revert back? Old value you did not store, how you can revert back? So that's why here undo operation is not possible. Here only redo operation is possible. Okay, but here redo and undo both are possible. Before recovery, system must perform the redo operation for the transaction and contain both start and the commit. Which one is contain both? Start also, commit also. It will do the redo operation. Where the only start is there but commit is not there, then it will do the undo operation. And here it is only able to do the redo operation. Is that clear? This is the main difference between log based recovery. I am going there so that it is not hiding. You can take a screenshot if you want to take the screenshot. If you want to take the screenshot, you can take the screenshot from here. That is what is deferred DB modification and what is immediate DB modification. You can take the screenshot. Yes, I hope you already took the screenshot. Clear? This is clear? Okay, now you can see here a question. From here one question was there. You can see the question. Try to do that. Try to do the question. Those who are watching, please hit on the like button, like, share, subscribe. These three things are very, very important. Now Unified Study family is 19K. Unified Study family is now 19K. You have to make it more, right? Try to add more subscriber, more followers. You have to share with more students. So 19K will go more. Every month you are supporting me, so you can support more, right? You are supporting us. Make a big Unified Study family. What will be the answer here? What will be the answer? Consider the following sequence of two transactions in the bank. Initial balance was this one. Now transfer this one under this, then apply this is happen. Now suppose the database crash before the log records this one, then which of the system is restarted, then which one is true? Which one is true here? Okay, answers are coming. Yes, option 2 will be the correct answer. Because in log based recovery, we must perform redo operation for those transactions that contain both start and commit log record. Right? And we perform the undo operation for those transactions which contain only start but not commit log record. Therefore, we perform the redo for T1 and undo for T2. Okay. So, in the option there was little bit mistake, because you can see here we must do the redo log record for this one, like this one, and redo log record, then redo log record for this one. Okay. So, here it should be undo. Actually, it was given redo, but it should be undo. because I have corrected that one. T1 start this one, then T1 A old value was this one, new value is this one. When the power failure, when suppose that just before the log this one is written, just before this one this is restarted, means what happened? For T1 start and commit both are there, right? For T1, T2 start is there but commit is not there. That's why what I will do, that as this one is start, commit both are there, so we will do here redo operation. Here only start is there but commit is not there. That's why here we will do the undo operation. So my answer will be sixth one will be undo, and after that second and third one will be redo. Got it? Yes. Now come to the protocol. From here so many questions came previously also. Different types of protocol. Very important. Very important. Theoretical questions are coming. Okay. Before came to class, I'll thank you. Thank you for that. So here the concurrency control protocol ensure the atomicity, consistency and isolation and durability and serializability. That is also required. So this is categorized in log based, timestamp and validation based concurrency. Three types you are dividing it. So log based, timestamp and validation based. Log based protocol are divided into more three part. These are the more three part. Simplistic log based, simple log based, pre-claiming and two-phase locking. Two-phase locking is also divided into three part. Strict two-phase locking, rigorous two-phase locking and conservative two-phase locking. These are also divided into more three part. Okay, so all of you are ready to learn this concurrency control protocol. Here this is theory and I will tell you if you all will be there, because today my daughter is in home, so I can continue definitely. If you all are ready, then definitely I can continue. Yes, yes, so that this chapter will be done, because it's exam time, right? We have to cover the chapter. If you are ready to cover, then I can complete it. Should I complete? Yes, all are ready? Yes, ready. Very good, very good. All are ready to complete. You are not feeling bored? You are not feeling bored, I hope. You are interesting? Yes, it's interesting. It's very interesting. Actually, it's interesting. It's theory, but it is interesting. It's theory, but it is interesting. Okay, chalo. So log based. Log based means here the locking is there. There are two types of locking. One is shared lock, another is exclusive lock. These are the two types of lock are there. Shared lock and exclusive lock. First of all, yes. First of all, shared lock. Shared lock means what? Shared means when all are reading. Everyone is reading. That is called shared lock. All are reading together. That is called shared lock. Okay. So shared lock, and next one is the exclusive lock. Exclusive means I will do work exclusively. I will not allow anyone else to do the work. That is called exclusive lock. Okay. So read only, it is giving you only the read only lock, and the exclusive lock means here the writing operation is also there. That is called exclusive. So when I am coming to the four types of lock protocol, first one is the simple lock. Simple lock, how it is working? This is the simplest way of locking the data. This lock based protocol allow all the transaction to get the lock on the data before insert or delete or update on it. Whenever you want to do some operation, before that only you will acquire the lock to do the work. means log that data, then do the work. So it will unlock the data item after completion. Before completion only you are taking all the data, you are locking all the data, you will complete your work, then only you will release all. That's why it is simple one. Implementing this lock without any restriction, that is the simple lock, or the binary locking. It is another name is called the binary locking also. But it have the disadvantage of it's not guarantee the serializability. Write down it. From here question came. Everyone must write down this one. Very very important, that it's not guarantee the serializability. It's not guarantee the serializability. From here questions are coming. Which one is giving which one is guaranteed serializability? Where the deadlock is there, where the deadlock is not there. From here questions are coming. So write it down everyone. Okay. So schedule may follow non-serializable schedule may be the result. To guarantee the serializability, we have to do the additional protocol, that is came now two-phase locking. Now it is coming to two-phase locking. So two-phase locking is ensuring the serializability. Two-phase locking will ensure the serializability. Write it down. How? Here first of all there will be the pre-claiming lock. Another one. This is another one, that is called pre-claiming lock. Pre-claim means before going all the list, to the list all the data, not only one data, all the data whatever I required, I have to pre-claim. The transaction have to pre-claim all the data item they need to log before initiating the execution of the transaction. Whenever you got all the lock, if all locks are granted, then only it will allow the transaction to begin. Like that I need 10 data. Out of 10, if you got 9 but 1 you did not get, you cannot start. All 10 data you have to get, then only you will start, otherwise not. If all locks are not granted, then protocol allow the transaction to roll back and wait for the all lock. If you are not getting, then roll back and wait for all, so that you should release the other locks and other can work. This is called the pre-claiming. Another one is now two-phase locking. What is two-phase locking? Here it is little bit updated. Unnecessarily it is not doing that I will acquire all the lock then I will start. It is just it is not that much good way, right? Ki you want to start your preparation. Now there are 10 units in your syllabus. Now whenever all the 10 unit material will be gathered, then only you will start the study, otherwise you will not start study. Is that good? Definitely not. So whatever resource I have, okay, let's start it. In between you can collect other resources, right? That is always good. So two-phase locking is also doing that. Okay, first of all whatever you have, start it. In between, at the time of running, you can acquire more lock. That's why here are mainly 3 phases are there. In the two-phase locking, you can see there is, why it is the name is two-phase, growing phase and shrinking phase. There are 2 phases. One is called growing phase, another is called shrinking phase. Growing phase, what is going on? When you are acquiring the lock. Growing phase means, in this growing phase, new lock will be acquired. It is started, the transaction started here and it's acquiring new lock. And now it's working at that time. And now here it's started to release the lock. That is called the shrinking phase. Shrinking phase means, in this phase, existing lock held by the transaction released, but no new lock can be acquired. And here none of them cannot be released. You can only grow, you can only take, you cannot release. And here you can only release, but you cannot acquire. That's why the name is growing and shrinking phase. Is that clear? Yes. Here another option is there. Okay, you joined just now. Okay, continue from now. Upgrading the lock is possible in the growing phase. Downgrading of the lock is possible in the shrinking phase. What is that? Initially you took the shared lock. Means you thought I need the read operation only. But now you are thinking, no, I need to do write operation also. So what you will do? You can update your lock to shared lock to exclusive lock. That is called upgradation. Upgradation possible in growing phase. In shrinking phase, you acquire the write lock, that is the exclusive lock. But now you are thinking, no, my writing task is done, only reading task is required now. So you can downgrade your lock to the shared lock. That is called the shrinking phase downgrading. The two-phase locking is very, very important protocol. From here so many theory questions are coming. Is that clear? Is that clear? And this chart is very important. From here you can get question. You can get the question. Very carefully check it. What is lock point? Here I am showing you this chart. Check the chart very carefully. There are the transaction going on. Here the lock. This is also lock. Here is the unlock operation. Then here lock, unlock B, unlock. Now from here they can ask you key, what is the lock point? Lock point means what? The point at that same time, what is called lock point, you can see here. The point at which the growing phase end. Growing phase ending in this point, that is called lock point. So here you can see where the growing phase end. If you zoom here, you can see here actually the lock point. Here it is end. Because here unlock started. For A, here the unlock started. In the transaction 1, it started unlocking here. And for the transaction 2, the lock end in the 6th one, and from here it started unlock. Okay. That's why the lock point for the T2 is 6. The lock point for T2 is 6 because here the last lock operation done. And lock point for the T1 is this one. 3 because it is the last operation for T1 lock. Okay. What is the growing phase? 1, 2, 3. That is the growing phase for T1. Shrinking phase is 5 to 7. At that time the unlock is going on. For T2, growing phase is T2 to 6. This is the growing phase. 2 to 6. Shrinking phase is 8 to 9. That is the shrinking phase. From here question can come. Very carefully remember it. Question can come. They can provide you this type of transaction, and from that transaction they can ask you question. Is that clear to everyone? Yes. Is that clear? Clear? Okay. Chalo. Now tell me. Now here you can see this is the cascade rollback and deadlock and starvation possible. In two-phase locking, serializability it is ensuring. It is ensuring the serializability, but still two drawbacks are there. What are the drawbacks? Cascading rollback problem can be there, And deadlock and starvation is also possible. Must write down in your notebook. These points are very important. Must write it down in the notebook. Cascading rollback is possible in the two-phase locking, and deadlock and starvation is also possible in two-phase locking. You can see here why this is the problem. You can see here the right operation done, here it's failed. Now it need to be rolled back. Now this transaction need to be rolled back. That's why it is possible. Okay, that's why this is the reason here cascading rollback is possible. And even also loop can be formed. Deadlock in two-phase locking, why? Because here the loop can be formed. Like the serializability, we draw the serializability in that. You can see here the precedence graph if you are doing, then the loop will be formed here. For the lock x1, then x2, then lock x2, then x1. So it will create a loop, and as it is creating the loop, that's why the deadlock is also possible. These are the two disadvantages of two-phase locking. Must write down. Theoretical questions are coming from here. Okay? Got it? So tell me, what are the points you understand from two-phase locking? What are the main points? Growing phase, shrinking phase. What is growing phase? What is shrinking phase? Tell me in the chat box. And serializability is possible in two-phase locking. That is the advantage. And what are the disadvantages of two-phase locking? What are the disadvantages of two-phase locking? Tell me. What are the disadvantages? Tell me. What are the disadvantages you learned? So these are called two-phase locking, growing phase, sinking phase. This is already done. Yes. Ashwini, Lakshmi Rana, Rohit, Prathiva, good. Not guaranteed what? Cascading rollback and deadlock. Yes. Cascading rollback and deadlock is the problem. Good. Very good. Very good. Now next one is the strict two-phase locking. This is the strict two-phase locking protocol. What is strict two-phase? Here you can see the growing phase is there. The first phase of two-phase locking similar here. That is the growing phase. This growing phase is here. You can acquire the lock and transaction continued the execution normally. Only difference is that in the strict two-phase locking that does not release the lock after using it. Here the shrinking phase, that is slowly release, was not there. Slowly no release. No release slowly. It waits until the whole transaction committed. Whenever completely it will be committed, then only it will release all the lock. Because it don't want to take any risk. Suddenly problem can be happen, right? Maybe now I am thinking that my work is done, but in between maybe that will be again required. Maybe there will be the transaction, there can be problem, there can be failure. So then again maybe my lock will be required. That's why it is trying to be safe. So I will not release any lock. I will start my very smart. It is starting work. Whenever I am getting some lock, I will start my work, and time to time I will acquire the lock. But whenever all lock I acquired already, I have started working, then before completion and before committing the transaction, it is not releasing any lock, so that it will be safe, so that is safe. So strict two-phase locking does not have the shrinking phase here. It don't have the shrinking phase. All the lock will be released at a time. After commit only it is ending. Got it? Got it? Yes. Clear? That is clear? So that's why strict two-phase locking is recoverable and cascadeless. It is strict two-phase locking ensure the schedule that is recoverable also and cascadeless also. That cascading problem is not there and it is recoverable also. Got it? Yes. This is the strict two-phase locking. And rigorous two-phase locking. Rigorous means it requires that the addition of the lock being two-phase, all the exclusive and shared lock held by the transaction be released until after the transaction commit. That's why it is recoverable and transaction also. That is called the rigorous. Okay. Addition. In addition, the lock being two-phase, all exclusive and all shared together. Another one is there, that is called the conservative two-phase locking. Static or conservative two-phase locking. That two-phase locking is called that it is the conservative two-phase locking is deadlock free. This is deadlock free, but not ensure the strict schedule. This is a deadlock free operation. Why? Because the protocol required the transaction to lock all the item at access before the transaction begin. Before beginning only it will take all the lock. By pre-declaring the read set and the write set. What are the read operation required? Where the write operation required? Where the shared lock required? Where the exclusive lock required? Everything it is predicting and it is taking. If any pre-declared item needed cannot be locked, the transaction does not lock any of the item. It is not locking any of the item. Because deadlock can be happen when? That you lock data A. Transaction 1 lock data A. Transaction 2 lock data B. Now transaction 1 is waiting for A. Transaction 2 is waiting for B. Any one of them is not getting any one and deadlock occur. But here why deadlock will be not there? It will not acquire any lock if all the knot is free. If T1 need A, B both, then whenever A, B both are free, then only it will lock the data. Otherwise it will not lock. So that if another one required, they can do it. And that's why there will be no chance of deadlock. That is the reason there is no chance of deadlock. Because when all are there, then only I will lock. Otherwise I will not lock. It is not locking anyone. It is not starting also and it is not locking also anyone. So that it is not creating any deadlock. That is a very important. From questions are coming. Which one is deadlock free? So conservative two-phase locking is the deadlock free. Okay, but not ensure a strict schedule. It cannot ensure the strict schedule. In the Venn diagram below, it can be classified in the universe. You can see this is strict. Under superset is the two-phase locking, then strict two-phase locking, then rigorous. Rigorous is more conservative. This is conservative one. Got it? Clear? Is that clear? This is actually some example of two-phase locking. Is that clear? All that concepts are clear? Yes, this is very important concept. Questions are coming from here. Next one is the timestamp ordering protocol. Timestamp ordering means that is also simple. The timestamp ordering protocol can by continue. Is it okay? Some little bit more topics are there. Are you okay with that? Timestamp ordering. Yes. If you are allowing me to complete, then I can complete. Because some students don't have the patience. I know that I am taking, maybe it will be a 2 hours class, and some students will work for 4 minutes. 4 minutes, 5 minutes. After that they will leave the class. Most of the viewers are like that. And sometimes that's why I'm getting little bit demotivated. Sometimes I'm feeling, oh my god, I can teach but student cannot take. I can teach but student cannot take. Is it okay? Yes. Okay. Okay. Okay, good. Chalo. If it is okay, then I will continue. And those who are watching, please like. Please hit on like button. Those who are watching till now, comment yes, I am watching seriously. I am watching seriously. And click a like button, share button. Yes. Okay, okay. Chalo. So next one is the time stamp ordering. Time stamp ordering is what? Here the time is a factor. Right. Here the time is the factor. The time stamp ordering protocol is used to order the transactions based on their timestamp. I am asking a question. First I will ask you a question. After that we will go for that one. Let me ask you the question. Tell me, what will be the answer for this one? What will be the answer for this one? Let me check you are able to understand or not. After that I will go right. Let me check you are able to understand the concept or not. What will be the answer for this one? Yes, all of you are giving correct answer. Very good. So option 4 is the correct answer. A transaction read the data item after it is written by the command committed transaction. Then only which scenario is irrecoverable? It is irrecoverable, right? Yes, it is irrecoverable. Very good. Very good. Now another question was there. Now I am not able to find out that question. As I will check the question. Somewhere the question was there. Okay, I will ask you question. Today evening I will ask you question. Okay, in the MCQ class I will ask you more question. I will add all the question together, and in the evening we will do those questions. Okay? Evening class we will do that. Now come to the timestamp. There in this chapter so many questions are coming. In the MCQ class I will arrange a MCQ class for transaction concurrency MCQ. Okay? Okay? So there we will discuss. Timestamp ordering protocol. Here the timestamp ordering protocol. The timestamp ordering protocol is used to order the transaction based on their timestamp. Ordering will be based on their timestamp only. So how the timestamp will work here? In order the transaction, it's nothing but the ascending order according to the transaction creation. Yes. Okay. 6:30, 6:45 I will do. Someone is telling 7, someone is telling 6:30. So that's why I decided previously also 6:45. Now also I am telling 6:45. Okay. So everyone will be happy for that. So the priority of the older transaction is higher. That's why the execution will be fast. Who is coming early, that will be higher priority, right? If someone came at 5 p.m. and someone came at 6 p.m., who will be the high priority? 5 p.m. will be the high priority. So whose timestamp is older, that will have the high priority. That's why determine the timestamp of the transaction. The protocol uses the system time or the logical counter. Either it will take the system time or the counter will be there. The log-based protocol used to manage the order between the conflicting pair. What are the conflicting pair? Read, write, write, read, write, write. If the conflicting pair is there, then the ordering will be done through the execution time. But the timestamp based protocol start working as soon as the transaction is created. Okay. Now just for example, you can see here the example transaction T1 and T2. Two transactions are there. T1 entered at the system at 007 and T2 entered at the system at 009. So who will have the high priority? Definitely T1 will have the high priority because T1 is the older one. So it executes fast, then T2 will execute. In that way, here the ordering will be going on. The timestamp ordering protocol also maintain the last read and write operation by the data. Who did the last read? Who did the last write? From this timestamp protocol, this type of examples are coming. They are giving this type of question. Today's MCQ will be in this chapter. Okay, be ready for that. So here, timestamp ordering protocol will give you this type of example. You can see that here the read X operation. If WTX is greater than TSTI, then operation is rejected. Why? Because the transaction TI issue a read X. Transaction TI want to do a read X operation. Now if for the TI the timestamp is less than, another one is there which is greater than this one, then it will be rejected. If it is less or equals to, then the operation will be executed, otherwise not. Okay, and the timestamp of all the data will be updated here. Here also another operation, you can see write X operation. Now an TI transaction try to do write X. Same way it will check that TSI, if it is less than by TSX read operation, then operation will be rejected. If this is less than write X operation, then also operation will be rejected and TI will be roll back. Here TI will be roll back. Here it is updated. All our data are the updated. Here it will be roll back. Otherwise that operation will be executed. These are the rules you have to remember. The rules are very important because question will come from the rule. Okay. So when T1 denotes the timestamp with TI, and here RXI means it is the read operation and this is the write operation. From here questions are coming. Is it clear to everyone? Is that clear to everyone? It will be given like that. How the question are given? Question will be given like that. T1 is the transaction. It's want to do read A operation. Read A operation. and another transaction is there, maybe another transaction is there, and it is already going on a transaction. Okay, on the data X, maybe I am doing a read X on the data X. Okay, read timestamp, it is read by someone, means maybe this read operation done by the T1 at the time 5 p.m. Now it's want to do again another read operation. It's want to do another read operation at the time 6 p.m. Here the time, last read operation time is 5 p.m. Current time is 6 p.m. Now it will be allowed or not. That will be checked. So here what is checking? The last write, that is write TX, that is the write timestamp. Last write operation is greater than by this one, then operation will be rejected. If the last write operation is less or equals to this one, then it will be executed. If it is greater than, then rejected. If it is less than or equals to, then it is executed. If it's want to do write operation, then it will check that last read operation, that is the last read operation, this current one, is it less than the read operation, then it is rejected. If it is less than the write operation also, then also it is rejected. Otherwise only it is executed, means when they are greater than. When they are greater or equals to, then only it is executed, otherwise not. This is the thing you have to remember. Okay, they will provide you timestamp, and for the timestamp they will ask you question. Clear? Is that clear? So here is the advantage of timestamp protocol. You can see the advantage. The timestamp protocol ensure the serializability. Since the precedence graph is as follows like that, because it is ordering is maintained, right? Here the smaller one and larger one, so ordering will be maintained. So that's why serializability will be maintained. Protocol ensure freedom from deadlock also. Means no transaction overweight. So there will be no deadlock. But schedule does not recoverable. It's not recoverable and not even cascade free also. These are very important to write down. This is not recoverable also and not cascade less also. Okay. So make a chart. I will suggest you make a chart. Two-phase locking, rigorous two-phase locking, strict two-phase locking, timestamp protocol, what are the difference, what is going on, and mainly where serializability possible, where deadlock possible, where the recoverability possible, where cascade less possible. This chart write down in a same page so that you can revise. That will be good for you. Next one is the validation based protocol. Validation phase. Validation phase is also known as the optimistic concurrency protocol. Why it is optimistic? Because the validation based protocol transaction executed in the following three phases. First phase is the read phase, next phase is the validation phase, and next phase is the write phase. Three phases are there. Read phase means only read operation will be done. In this phase, T only read and execute. Read and execute will be there. It is used to read the value of the various variable and store them in a temporary variable. Validation means here the validation is going on. In this phase, temporary variable value will be validated against the actual value to see the serializability. If the validation of the transaction is validated, then the temporary result will be written to the database. Otherwise, it will be rollback. That is the three phases here. That's why it is optimistic. I will validate first. If validation done successfully, then only it will be written. Otherwise, not. Otherwise, it will be in the temporary variable only and it will roll back. Okay, So that's why here these are the three phases. You can see start Ti, then valid, then finish. These are the three part are there of the validation based protocol. So this protocol you can see determine the timestamp of the transaction for the serialization here. So validation based protocol is actual phase, are these are the phases are here. So serializability is determined during the validation process here, and it cannot decided in the advance. Serializability you cannot do in advance. So while executing the transaction, its greater degree of the concurrency number will be conflict and less number will be less number of rollback are there. There is rollback is there, but number of rollback is less. Number of rollback will be less, and it ensures the greater degree of concurrency and also less number of conflict. These are the points are very important. Degree of concurrency, which one is giving you degree of concurrency, that is validation based protocol, and less number of conflict is also happen in validation based protocol, and less number of rollbacks are also there in validation based protocol. Okay, got it? Clear? Clear? ठीक है? Serializability previously it cannot be. It cannot ensure previously because serializability checking is done in the validation phase. Because serializability checking is done, the serialization will be done using in the validation phase. That's why initially it cannot do. Initially it is not able to do. That is the problem. Okay. Next one is the Thomas rule. What is Thomas rule? Thomas Wright rule provides the guarantee of serializability order. It is guarantee. It's always guaranteed the serializability order. This is the only one. For the protocol, it's proof that basic timestamp ordering algorithm. Okay, degree of concurrency is less and yes. So the basis of Thomas Wright rule follows this one. How? The TST means the current one is read operation less than. If it is less than the read operation, then transaction T is aborted and roll back, and operation will be rejected also. And if it is less than the write operation, then does not execute the write item X, and operation transaction will be continued the processing. Any write operation will be not executed here. Remaining one will be processing will be done. So if condition 1 nor condition 2 occur, then allowed the execution to write operation by transaction T1. So if the read timestamp of reading is greater than of current one, then it will be aborted and roll back. If the write TX is greater than the TS, then it will not execute any write operation. Any write operation will be not executed here. That is called the Thomas rule, and here it is guaranteed the serializability. You can see here how it is possible. If Thomas Wright rule, some serializable schedule permitted does not conflict Syria. Here you can see A, then it is committed, then this is committed. A serializable schedule that not conflict serializable. This is the figure in this figure. So the T1 read the process and same data of the item, so does not conflict serializable. It's not conflict serializable. If it is not maintaining, if this is not maintaining that. But here what will be happen? The Thomas Wright rule checks that T2 write never seen by any transaction. If we delete the T2 operation, you can see here if it is deleted. If I am deleting this as per the Thomas rule, write operation in T2, then it is conflict serializable. Then there is no problem because the A then write, here is nothing. Here is nothing. Write operation is not there. That's why Thomas rule is ensuring it. The Thomas Wright rule checks that T2 write is never seen by any transaction. It's not there. I will not check it. I am ignoring, right? Here what it is going on? It does not execute the write operation. If the write operation before that is going on, then it will be not executed. It will ignore. It will not execute and it will ignore. And remaining transaction it will do. So if I am removing it, think like that this is not there. I am erasing this part. This write operation I am erasing. It is not there. Then so it is serializable, right? Then I am getting this one and it is serializable. That's why Thomas rule is always guaranteed you to serializability, because it will follow this rule, because it is following this rule. If write is less than this one, then I am ignoring it. It will not allow anyone. That's why it can guarantee the serializability. Is that clear? How it is guaranteed the serializability? Is that clear to everyone? All the rules and all these points, which one is serializable, where serializability not possible, where possible. Is that clear to everyone? Yes or no? So our all topics will be covered. Clear? Recovery is different. Till now these protocols was there. So all the protocols we done. So take a notes of all the points. Must take a notes of all the points whatever you done in this class. All these points are very important, as I told that from the first protocol we started when that was the 4-type protocol. First one was the two-phase locking, shared lock, exclusive lock, simple lock, pre-claiming lock. Then we did the pre-claiming here, two-phase locking, here, and after that the strict two-phase locking, then rigorous conservative two-phase locking. Then after that we did the timestamp protocol, and under timestamp protocol then validation protocol, and after that the Thomas Wright rule. These all are done now, and these protocols are very important. Must remember all that and prepare a notes, as it is a theory. So many topics are there together, so you have to prepare a notes. I took that class, I completed this chapter. It is near about 1.5 hour, 90-minute session. In this 1.5 hour you learn the complete transaction concurrency protocol, all types of protocol. Questions are coming from here. Take it very seriously and complete it so that you can cover everything. Okay, we will practice the question. Today evening I will arrange the session for practice session of transaction and concurrency question, so that your all this topic will be done. Okay, take care. And remaining subjects, remaining topics of the DBMS is already there in this playlist. You can see that is serializability. This video I am zooming little bit so that this part will be visible to you. See here, these are the videos. I will suggest you must watch those videos. The first one is the functional dependency, this video. Then this is ER diagram video, SQL, serializability, and today I took the transaction concurrency. Okay, these are the videos, these are the chapters, are very important chapter. Must complete this chapter so that you can guarantee, assure your marks in database. Okay, and there is some more classes. I will add those classes, and whatever remaining classes are required, that I will take it. And remaining all these classes, that is networking also, I have added so many classes. RSA, cryptography, subnetting, sliding protocol, network flow control, fork. These are the operating system classes. All these operating system classes I added there. Must watch all the classes. Here computer architecture classes are also there. theory of computation classes. Complete all these classes. These classes will be very much helpful to you. You can see so many classes are there in this course. If you cover this all classes, then in your exam you can do a good score. Okay, bye everyone. And those who are interested to take our course in Unified Study, definitely you can go for the paid course. As you know that here our offer is going on Super 20. This offer is till this weekend only, in this Sunday, till this Sunday, that is date is 6th November. Till 6th November the offer is there, Super 20. Using this offer you can take this subscription, that is this combo batch. I will suggest you can go for this combo batch. 2500 you can get it in 2000. You can get it in 2000 only. Okay, video already there. SJF scheduling video already there. Operating system video already there. Operating system CPU scheduling, watch this video. In this video CPU scheduling I already uploaded. It is already there, you can check it. Here CPU scheduling, I know, here all CPU scheduling. Must watch this video. All this CPU scheduling is here. Okay, you can watch that video. Must watch it and you can get it. Okay, CPU scheduling, all these videos are there. And those who are interested, you can go for it. Okay, and you can take, if you are interested for paper 2 only, then also you can take it. This one you can get in 1600, 2000, but after discount you can get in 1600. Paper 1 you can get in 800 you can get it. So whatever your choice, and all PDF, if you need only PDF of the courses, that 45 days course, this PDF is available in this 999. Now the offer is going on, you can get it in 799, because here all the PDF I have uploaded. If you come here, you can see all this PDF, chapter wise, subject wise, all the PDF are there. I have uploaded all the PDF here. Total complete operating system, complete DBMS, all this PDF. If you open this DBMS, you can see the complete DBMS PDF is there. Okay, so complete DBMS, operating system, networking, computer architecture, TOC, all the subjects PDF are available in this course. If you want to get that, then in 790 you can see 532 pages. If you zoom, you can see there, this is the 532 pages PDF. Here it is a 532 pages PDF. You can download in your mobile or laptop and you can get it. So all the subject wise PDF is there. So it's your choice. If you want to go, you can go for it. Okay, bye everyone. See you again tomorrow. See you again today evening 6:45 to 7. Within that time I will come live.